Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. This happens to be a question about my June 2026 Ask Dave column in QST. Now, the June column has been out since the beginning of May. A number of people have read it, and the last little story in here is about antenna reciprocity. Now, the normal idea is that an antenna will receive about as well as will transmit. So if you've got like a beam and it's got 12 dB gain pointed in the right direction, it will have 12 dB gain on the transmit and 12 dB gain on the receive. Most common, all common antennas work that way, okay? Now, there's some things that you can do. Different types of antennas behave in different ways. For example, a vertical antenna in a crowded neighborhood can pick up quite a bit of man-made noise simply because the man-made noise is mostly vertically polarized. Also, if you put up a dipole, you can have the same amount of gain as the vertical, and you'll get that on both receive and transmit, but the vertical might give you a little bit more noise. Now, another antenna, and this is one mentioned by, let's see, this is Mmotsenbocker, who is a member of on YouTube, and thank you for that support. It actually comes from improving receive performance on 80 meters, number 1364, but he asks about a beverage antenna for receive only. A beverage antenna is a lousy antenna. It's got a lot of loss, not gain. Okay, it is a reciprocal antenna. However, being so close to ground, if you're doing one for 160 meters or even 80 meters, you want it to be about 8 feet in the air so that two things don't happen. One, your neck doesn't get guillotined by it. And second, some poor male deer with a big rack doesn't run under that thing and get flipped over on his back or break the antenna, okay? Now, what is so special about a beverage? It's a terrible transmitting antenna. So you use a normal antenna to transmit, okay? But on receive, the noise picked up by the beverage antenna is very low. So low that it's much less than the noise picked up by the normal transmitting antenna. So if you tried to transmit with your beverage, would it work? Yeah, but it'd be a very lossy antenna. But as a receive antenna, it's a very lossy antenna, but there's very little noise because it runs parallel to the ground. And it is slightly capacitively coupled to the ground. Usually you terminate it in its characteristic impedance, 150 to 200 ohms or whatever. You don't need a very big resistor since you're just doing receive. But note that an antenna that long, it needs to be at least a wavelength long and should be longer, can pick up static electricity and so on. So you want to make that resistor at the other side fairly hefty. Not a wire wound resistor, but an actual resistor, okay, so that it can dissipate that. The reason is any energy, it's a wave antenna, it's not a dipole, it's a wave antenna. By the time the energy gets to the back, to the end, it's dissipated. But if there's no termination, it will work in reverse the other way. So you end up with a bidirectional antenna. A beverage on the ground is very directional. Now, what do you use 160 meters for? If you use the DX window down at the bottom, you can talk to Europe fairly well at certain times of the day, you know. And let me show you on the whiteboard here. Okay. His question has to do with the beverage antenna. A beverage antenna is significantly greater than 1 wavelength long. Okay, it's a long antenna. If you're going to do this on 160, you need 3 or 4 acres for this antenna. The distance above ground is about 8 feet. You can also do it right on the ground. Some people like to do that, but you need dry ground to do that. If it's wet ground, it's too close to the ground. But about 8 feet gets it up above people, and then it's terminated in its characteristic impedance. And then here you've got you'll probably have a ferrite type thing. You've got a 3-to-1 transformer here. If it's ferrite, I'll go ahead and put the core in here. Okay, so this is 50 ohms. This will give you 3 times that, or 150 ohms. You can experiment with that. But the idea that this is long and low. Now, if you look at a beverage antenna from the top, here's your house, here's your trees all over, whatever. The beverage antenna goes out in a direction like this, straight. Now, the directivity of this, if you were to look at the antenna's pattern, it's actually quite directional in this direction, okay? And if you terminate it properly, it's not sensitive to stuff coming from the backside. One of the problems with the beverage antenna is that it's not something you can rotate. So what do you do if you need more beverage, you need more coverage? Well, multiple beverage antennas, and you select the one that you want, okay? Now, on 160 meters, 80 meters, about the only practical antenna is either a dipole, inverted V, a dipole, an inverted V, or a heavily loaded vertical. Now, the problem I say that is because this antenna has to be, if it's going to be a real vertical, it's got to be 1/2 wavelength long. 1/2 wavelength on 160 meters. A vertical on 160 meters, that's 40 meters high. That's about 66 feet high. Still, that is a really tall tower, okay? As high an antenna as you can, put a capacitance hat on the top and a loading coil on the bottom, recognizing that this is quite an inefficient antenna, and it will probably only tune a very narrow range of frequencies. But that's fine. If you've got a pine tree that's 60 some odd feet high, get to climbing, okay? Take that up there safely, of course, and you can make an antenna like this and then tune it until it works on the frequency that you want it to work. This will transmit equally in all directions. It is possible. This is something I've never really talked about. If you have a vertical here, you can put a vertical here, like 1/4 wavelength apart or something like that. Another vertical here, and depending on how you phase these, it can make this quite directional. This is how AM broadcast stations, usually here's looking down at it, here's the city, okay? And so you'll have these 3 antennas outside the city, but phased so that their pattern is like that. And they've got it's a cardioid pattern, and it's got a null back here. This is a lot easier because real estate is a lot cheaper out here than it is in here. All right? Plus, the city may not let you put up a great big giant antenna out there. Now, the broadcast AM antennas are usually a 1/4 wavelength high, and that's really tall. So there you go. And we ought to fix that part where I first talked about the 160. Okay? So let's see what else we got here. He's talking about whether he can connect several beverage antennas together. Now, if you do, you're going to split the power between the antennas, which will play havoc with your SWR. So you have to readjust everything and do that. And it covers a very broad area, but doesn't give you the real directivity of any one of them. So what you're going to need down here is an antenna relay to see which one you connect to. Okay, and these are connected, you got a vertical antenna right here, these are connected to the hot part, not the ground part. Okay, the part of the beverage has got a resistor, and then it is connected to ground rod out there, if you want to do that right. Okay, these are hot right here, not grounded. All right, so you can go ahead and put your vertical up, put this here. Now note that the vertical you will have tuned for 50 ohms, and the beverage system, including the coils here and stuff like that, is also 50 ohms. So you got a little bit of a problem because it's going to split this, and your SWR will be 2-to-1 because you're putting that put that in parallel, that's 25 ohms. You've got a 2-to-1 SWR. You don't really want that, okay? So what you are going to need to do is put an antenna switch out here. When you are receiving, switch out the vertical, okay? and switch in one of the beverages. You must have a huge estate, okay? And if you are, then when you transmit, you want to switch out the beverage and switch this one in here, okay? So there you have it. I hope that answers your question. You don't want to connect them in parallel because of the impedance problem, okay? So Mr. Mmotsenbocker, who is a member, and again, thank you very much for that. I hope that answers your question. If you would like to ask additional questions, please do so. Okay, there you have it. Until we next meet, 73.